Welcome to our today's lesson. My name is Mwalim Samyamu. In our today's lesson, we shall be tackling the topic on bonding. More specifically, we shall be looking at the ionic bonds. By the end of the lesson, ensure that you can state the term ionic bond. You can demonstrate the formation of ions that result to formation of ionic bonds, and finally use atomic diagrams to illustrate the formation of ionic bonds. An ionic bond is a bond that is formed as a result of electrostatic forces between atoms. What do I mean by this? We have an atom that is positively charged getting attracted to another atom that is negatively charged. Remember, the basic law of charges states that the like charges repel while unlike charges attract. So the charge on A being positive and the charge on B being negative results to an attraction between the two atoms or the two particles. So ideally, that is how an ionic bond is usually formed. Ionic bond can be defined as a type of a bond that results from complete transfer of electrons from one atom to the other one, depending on how we shall be showing or demonstrating that one. As an example, we will use sodium chloride, the table salt, as our case example for this case. Sodium atom forms a charge and becomes positive, while chlorine forms a charge that is negative, and these two atoms now attract each other. This type of attraction is the one that we call electrovalent attraction, which results to formation of an electrovalent bond, which is in other terms referred to as an ionic bond. We look at how these ions are formed. Sodium has an atomic number of 11. This means that it has 11 protons and it has 11 electrons. On the other hand, chlorine has an atomic number 17, meaning that it has 17 protons and 17 electrons. Okay? From this, the electron configuration of sodium, we can deduce it to be 2, 8, 1. While that of chlorine is 2, 8, 7. Remember, for atoms to combine or all atoms to react, they have to obtain either a duplet or an octet state, whereby their outermost energy level must be complete. So for sodium, it requires either to lose this one electron or gain 7 more electrons to have an octet state of 8 electrons in the outermost energy level. Now, because it is easier for sodium to lose 1 electron than to gain the 7 electrons, sodium will lose this 1 electron and it becomes a positive ion. This is how that one happens. We have sodium atom, then it has 1, the first energy level, with 2 electrons. Then we have the second energy level with 8 electrons. And then we have the third energy level with only a single electron. So for sodium to be stable, it loses this outermost energy electron to form an ion with a positive charge. When that happens, a sodium ion is formed. And how is a sodium ion? How does a sodium ion look like? A sodium ion looks like that, having a positive 1 electron. Why is it positive 1? Remember that initially sodium had 11 protons and 11 electrons, meaning that there is a balance between the charges. So losing 1 electron means that it has 11 protons and 10 electrons. So there is an excess of a negative charge simply because electrons are negatively charged and the protons are positively charged. So an excess of the protons is at positive 1, and by that case we have now the charge for the sodium ion becoming positive. Let us look at how the atomic structure of chlorine looks like and how it forms its ion. Chlorine, on the other hand, has a total of 17 electrons and 17 protons. Its atomic structure looks like below. We have chlorine, then we have the first energy level having 2 electrons, then we have the second energy level having 8 electrons. We are getting the 8 from, remember that the electron configuration is 2, 8 is to 7. So the second energy level has 8 electrons. 1, 2. And then we have the last energy level with now 7 electrons. Therefore, for chlorine to attain an octet state, it can either gain 1 electron to make this one 8 or lose the 7 electrons in the outermost energy level. Because gaining 1 electron is easier for chlorine, and that is it for all the nonmetals, chlorine will gain an electron to form a chloride ion. And a chloride ion has a negative charge. Why is it a negative charge? It is a negative charge because while chlorine atom has 17 protons and 17 electrons, the chloride ion has gained an extra 1 electron. And by that case, the ion has an excess of 1 electron. It has now 18 electrons and 17 protons. That means that the negative charges are in excess of 1. And for that case, now we have negative charge for chloride ions. Now, you note that we said that chlorine gains an electron. And the question is, where is this chloride ion or this electron gained from? We will be seeing that one in a short while. So the electron that is gained by chlorine atom to form a chloride ion is usually gained, in this case, from sodium atom like this. So that now we have this electron being transferred all the way to chlorine, and then as a result now a chloride ion is formed like that. And then after now the transfer, we no longer have this electron, and that energy level of sodium is lost. Now from this case, after the electron has been lost, now we can first check when we have this electron, the atom here is sodium atom with an electron configuration of 2, 8 is to 1. Okay, while that one of chlorine, before gaining of this particular electron, the electron configuration of chlorine is usually 2, it's 2, 8 to 7. And then after now the electron is transferred to chlorine, this electron is lost in sodium, and then it is now gained in chlorine. As a result, the sodium ion is formed, which is positive, and then the electron configuration changes to 2 is to 8, while the charge for chloride ion now is negative, and the electron configuration changes now to 2 is to 8. And that is how simple an ionic bond between sodium and chlorine is usually formed. Having looked at how the sodium chloride bond is formed, we can now consider looking at how magnesium oxide is formed. The atomic structure of magnesium looks like we have magnesium with 3 energy levels, with the first energy level having 2 electrons, the second energy level with 8 electrons, and the outermost energy level with only 2 electrons. The atomic structure for oxygen, on the other end, has got 2 energy levels, with the first energy level with 2 electrons and the second energy level with 6 electrons. This means that from the fact that magnesium, the electron configuration is 2 is to 8 is to 2, while that one of oxygen is 2 to 6, meaning that magnesium requires either to lose 2 electrons to have an octet state, or to gain extra 6 electrons to have 8 electrons in the outermost energy level for it to be stable. Now, because it is easier for magnesium to lose 2 electrons than to gain other 6 electrons, it will lose the electron. But to where? We will be seeing that one. While for oxygen, the electron configuration is 2:6, and that means that it can either gain 2 electrons or lose the 6 electrons to have a complete energy level having 2 electrons, that is for the first energy level that accommodates only a maximum of 2 electrons. And now, because it is easier to gain 2 than to lose, sorry for that, so oxygen will gain 2 electrons to form an ion. And where will it gain those electrons from? It will gain those electrons from magnesium. So magnesium will transfer its 2 electrons to oxygen. And in that case, this outermost energy level of magnesium is lost. The very time these electrons are lost, the energy level is like it is normal. And therefore, this one leaves magnesium with a charge of +2. We write it better as 2 positive. While oxygen, after gaining these 2 electrons from magnesium, it gains the 2 electrons, and then a negative charge results simply because it has an excess of 2 electrons. That is to mean that it has a total of 10 electrons and 8 protons. And therefore, because the negative charge is higher, we have the ion of oxygen having a charge of 2 negative. So from this, a positive charge and a negative charge from magnesium and oxygen respectively results to the formation of an ionic bond between these two elements, and as a result this type of a bond is formed. So we have an ionic bond that is formed, resulting, and it looks like that. The next bond is the bond between aluminium and chlorine, and I wish to give you an assignment to maybe try out yourself and see whether you are able. Remember that science is learned through practice, and see whether you can be able to draw to represent a bond between aluminium and chlorine. You can pause the video, you try to do it, and then come back again to check whether you got it right. I hope you're back, and this is how the structure of the ionic bond between aluminium and chlorine are formed. Like you can see, we have aluminium with a positive 3 charge, and note also that we have introduced a 2 here and a 3 here, and that one is for the purpose of balancing. If you write the chemical formula for the reaction between aluminium and chlorine, you will be able to note that there is a 2 and a 3 in front of those two elements. This is how the 2 and the 3 comes along. We have sodium, we are looking at aluminium, which is a solid, reacting with chlorine, which is a gas, to give us aluminium, and the formula of aluminium chloride looks like this. Sorry, it's supposed to look like this. Sorry for that. There is no 2 here. So that now we are able to have aluminium. I'll just draw the equation again. Aluminium, which is a solid, plus chlorine, which is a gas, to give us aluminium chloride. So this is the 3 that is in front of the chloride atom. And where does it come from? It comes from balancing. Remember, for you to balance this equation, you need to have you can have 6 there, and then have like 2 here and a 2 here. The equation is not balanced. So how do you do to balance the equation? We have 2 aluminium, then these are 6 chloride atoms. So how do you make this one 6? You just need to have this one as just 3, so that now we have 6, 3 times 2, giving us 6 chloride atoms, 2 aluminium atoms, 6 chloride atoms, and 2 aluminium atoms, and the equation is balanced. Ideally, that is all about ionic bonds. In our next video, we will be looking at covalent bonds. I want to emphasize that for you to be able to understand, if you haven't understood so far, you just need to play the video again, and once you are sure that you have understood the ionic bonds, now you can go ahead and watch the next clip on covalent bonds. Thank you for watching.